This is Ben from Common Knives, and you're listening to the High Carbon Podcast.
Welcome, everyone. The Commander-in-Chief is back from the U.S. But I have to say, before you guys jump in, you guys did a great job while I was gone. I had some awesome guests on. Lots of chat and stuff going back and forth on Instagram about these new reels that we went back into. And some people were really attacking Paulie and felt like he did something wrong. But I think all three of us agree it was just stuff that was said on the show. If you guys haven't read any or seen any of the videos, you should go back and listen to the episodes, and you'll get a little bit more detail about it. They're great, and we're going to continue to do them. So keep reading them, keep watching them, listen to the episodes. You guys, we have a guest with us tonight. Are we going to skip what we're doing this week, or does anybody have anything exciting? Albert, you didn't do anything, right?
Oh, it was puppy training.
Like
all day.
Training.
Yeah, and we have a guest, Smith, at our shop.
Yeah.
Kutgat, I told you.
Yeah. Was he coming by to do some forging? Or?
Yeah, he will be with us all week, and he has some special projects he wants to do. Like, again, Apex Pro Cut Damascus. Again, his blade made into Blade Magazine. Did you see that?
I did, because when I went back to the US, I picked up my subscription the last 6 months, and I sent him a message, and I was just getting to open the magazine too. He just got a copy of it also, which is really cool. So that's the steel that he made at your shop, right?
Yes.
Last time he was there?
Yep, with our help.
I was going to say he probably didn't even know he was going to get in the magazine, but he talked with Laren firsthand. Or...
Yeah, he did, because Laren was writing an article for Blade Magazine, and he asked if he could use his picture and his blade, the Propax Damascus blade he made at our shop with the chevron pattern. And he's going to do some of that again while he's here. So he has a very ambitious goal this time. He wants to forge Apex Pro Cut Damascus, twist it, and forge a half integral out of it. That's pretty ambitious. So that's why he's here all week.
And maybe we'll see some of those at Knife Show Austria next month.
We might, yeah. I mean, it's for a custom order, so it's already been sold. He might bring it if he finishes it on time. If everything works out. So
cool. Paulie, anything going on? You look tired.
I have quick 3 things about the reels, bro. Sure. Ain't making 20-minute reels with all of the context. What the fuck? If you say something on air, hell, I'm gonna clip it. Hell, I'm gonna do it. Don't say I have a hot take and I'm gonna fight for it, and then come to my DMs and bitch about it. Don't do it. Just don't.
He did say fight me, right? He said what he had, then he said fight me.
Yeah, he said fight me. Ryan said, I'm gonna fight for it. Yeah, fuck carbon steel. And then he's like, I don't want to fight for carbon steel. They're so bad for me in the comments. Help me. Yeah, bro. Under a minute. Reel is under a minute. I cannot put in all of the context. And people then go and listen to our show and find out everything. And of course, there was a shitstorm in the comments. And it was so entertaining. Because people come with some, fist swinging. They're like, it's crazy. It's good. And they take it way too personally. I think podcasters used to have like way thicker skin, and now they are like just a little bit bitchy. So that's the first thing.
Can I jump in? Because I was so mad when I read the comment that we were throwing people under the bus. That's simply not true. If you have strong opinions and you can say them on our show, then have the guts to defend them on Instagram as well. So we didn't put out anything that was wrong or anything that wasn't said on the show. Literally, I mean, it was a direct quote from our show, right? So if you have strong opinions, there's nothing wrong with it, but then don't be a pussy when you have to defend them.
Exactly. And you would say context matters. And the context is fully available, fully free. Just go listen to the show and you get the whole tale.
Yeah.
No?
I mean, that's an argument that's been going on for ages. Stainless versus carbon. It's mostly opinion. I mean, I don't understand why people got so offended. But I saw a trend while I was gone, coming back on the long flight and stuff, listening to some of the episodes that I missed while I was on vacation. These other podcasts that are complaining about us, I think they have some other bigger issues to take care of first, with these ad problems and the audio levels. reading ads that you can't even underhear, people calling on a phone that you can't understand what they're saying, and they're worried about us. I mean, I don't know.
Yeah, they worry too much. They should look what
That's
they
it.
do. They worry too much. And we did not lie about anything. We just copied what they said. And maybe it was short, but some things were said. At least we were not lying. Like the guys on Hustle and Grind. They are lying all the time, apparently. Feed pics. I received no feed pics from Ryan. They just stole my design. I stole their bit. What the fuck? I'm a long-time listener now. Bros, you are way above it. You are way above it. Don't fall too low. Don't lie. You don't need to do that. And just ripping off my design. Sure. Okay. Thanks. Healthy community.
Only they asked you on the show.
They did.
So we have to be honest about that. So yeah,
it's good.
It's
they
fine.
asked. We traded. They did not like that. I am not interested in dogs. I'm not. I don't hate dogs. We became clear on that. I'm just not interested in having a dog. And we traded my design. Some more kudos. Tagging me more would be better, but they do what they do. And the third thing, the last thing I promise, until Knife Show Austria, I'm in a competition with Silesia Custom Knives, who can get first to 5,000 followers, which is fucking stupid, because it's like in 3 months?
Yeah. Not even, like
3 months?
2 months, almost 3 months.
Yeah.
Something like that.
Yeah, and it took me 8 years to get to 4K. And the loser has to wear a t-shirt that the other one made specifically for this event. Look, guys, if you want to unfollow me, just do it. I'm a great loser. I think I'm a way better loser than a winner. My favorite number is number 2. I mean, I love to be the underdog. It's fine. It's good. If you want to follow me, follow me. Also, Przemek, Silesia Custom Knives, made a fantastic reel about he will do a giveaway of his knife totally for free if me or him reaches 5K first. So it does not matter. So you can just follow us both, and it won't actually matter because we both then reach 5K and he does a giveaway.
Are you doing a giveaway, Paulie?
Never. That's the most.
He doesn't give stuff away.
So, dear listeners, unfollow Paulie and follow the other guy. That's what I did.
You look. Can I give my perspective here?
Of
please?
Course.
I defend it. This needs to be a healthy competition, right? We gain organic followers, no bots, no ads, no nothing, right? And when you give something free away, you get the followers who just want the free shit. In my opinion, it's no bueno way. No bueno way to go, because
he's going to have fake followers. Is that what you're telling us?
Not fake followers, but followers who are expecting to get free shit. And I would like my followers to follow me for my shit that I do and that I sell. So it's fine. It was his decision, and I fully support him. But I won't do the same, and I will have to learn some TikTok dances, I guess. If I need to plead for followers, I will. Pleading is cool. Begging is cool. Come with me. 5K, 2 months. I need, Jesus Christ, 350 followers in a month.
We don't care who wins or loses, because the rest of the audience besides you.
I do.
I do. I'm going to get something out of it. It's going to be funny.
It's going to be funny. It's going to be good. Albert cares. He said he unfollowed me. It's fine. I thought it's your choice. You can do it. You can do whatever. It's cool. I love the competition. It's actually adding a little bit stress to my daily life, but that stress turns into thinking about what cool reels I could do. Of course, I shamelessly stole one reel idea from Noah Bloomberg, who stole it from just
like a million other people. I mean, that's become a meme now. The Netflix documentary thing. I mean, he didn't invent it. Oh.
But you did it awesome. I love how you adjust the mic and gave a little thumbs up and the little eye wink at the end. It was you did it really good. It was perfect.
Yeah,
it was all intentional because I knew he will come at me. And he was the first one to comment like, "Oh, stealing my shit, bro. It's a trend. I don't steal your shit." So it's so funny. It's so good. Albert left a very, very good comment. Like every, could you repeat it? Do you remember it?
Every bait contains the promise of a trap or something like that.
And he fell into my trap. It was so good. Brilliant comment. So That's about my week.
Nice.
How about you, Keith?
My week. Just been doing a shitload of computer work, catching up on all the orders that I missed while I was gone. So I had like 2 weeks of orders backing up and taking care of a bunch of stuff with my truck. So I will be working on getting some new folder parts. I got all the folder screws, parts, and pivots and all that stuff and bearings up on my website. I'm just waiting on the pivots. They had a little problem. The people who were making the pivots did a quality control, and there was a bunch of them where the threads were screwed up. And yeah, so a little setback with that, but I'll be getting another company to try and make some of these pivots for us. I mean, they're small with like 3mm and 2mm threads, so I'm sure it's not an easy job, and it's hard to find people who want to make those in the quantity that I need without going crazy. So just trying to get that folder stuff all situated and looking for a new shop. Looking a little bit more into a new shop. So
do you have like requirements on how big it needs to be or how close it needs to be? Or
yeah, I'd like to keep it kind of close to home, close enough so that I'm away from anybody who just stops by randomly all the time. Albert, I know Albert likes that. You guys play foosball and drink beer with everybody who stops by, but that interrupts my whole entire day and I'll never get anything done. So far enough away that doesn't happen, but still close. So it's not like you have a long ride. 45 minutes is too far.
it sucks. Success. I mean, terrible. I would not recommend.
But you just moved to your new shop, Keith. Is the new one already too small?
It's getting tight in there, and not only that, but like I told you guys before, they're going to be renovating the rest of the shop. My shop, there's a big garage attached to it and a house that nobody lived in for a while. That stuff's really in bad shape, so they're going to tear the house down and put a new roof on it and all kinds of crap. So he wants me to like move my stuff to the second floor, and then they can finish the first floor and then have me move down again. And I don't want to move twice. Like if I move all that stuff and then the shop becomes too small to move again later. Plus, I probably have with the G10 sheets and all that stuff, I probably got a couple like tons of material, and I don't want to carry all that shit up the stairs and back down again later. So.
Sure, yeah. How many square meters are you looking for?
Like around 150, 200, something like that. 200 would probably be good.
Okay.
You can go a little bit bigger than what you need. As soon as you get a bigger space, you always find something to fill it with. So
sure.
But anyway, we have guests with us tonight. What do you guys think? Should we get into that?
Yes.
So our guest for tonight, I've been following him for a while. I think Paulie also. He kind of disappeared in the last year or so, but I think he's going to explain that to us. He makes awesome knives. He's from the U.S., San Francisco. Tonight we have Troopah Knives, and I'll let you, Troopah Knives, say your first name again so I don't screw it up.
Yeah, I'm Malachi of Troopah Knives. And yep, I was out of San Francisco, grew up there. But now I'm out in, Lakewood, Colorado, which is right near Denver, doing a PhD in metallurgical engineering.
Very nice. So that's why you haven't really been around on Instagram lately?
Yes, shockingly, that sort of thing kind of keeps you busy for a while.
Yeah, I can imagine. But you're making awesome knives, and you really don't have a lot of followers on Instagram. It kind of surprises me. How long have you been making knives, and like what got you into it?
Yeah, I mean, I've been doing knives since I was middle school, probably 14, 15 years or so now. So quite a good chunk of my life. But I don't know how I got into it. I came from a cooking family. We cooked all the time. You know, kitchen was the center of the house sort of thing. And I'm guessing I just got into knives through that, decided I wanted to try to make one. Got a janky forge like we all do, and tried to make a first knife, and it was terrible. Made a second knife, and it was slightly better, and so on and so forth, till they started turning out pretty okay.
So starting at 14, 15, I was going to ask you about your logo. I guess that would probably explain it at that time.
Yeah.
Knives, you were into video games.
Yeah. A little bit as a kid.
Does that have any other meanings with the Troopah Knives and the logo? No. Okay.
Not particularly. It's just, what you come up with when you're 14 and you're trying to sort out a logo for the knives you make. But I think it's pretty fun. So I'll probably stick with it unless I think of something brilliant in the future.
So what kind of knives do you primarily make for the people who haven't found you on Instagram?
Oh yeah, of course. So I do all chef's knives. I mean, I just don't really know what would make a good hunting knife, really. So I don't mess with that sort of stuff. But I do all chef's knives, all shapes and sizes. Mostly in kind of a hidden tang cross between like a Japanese and a Western style blade. But the big thing I'm interested in are the steels. I have always been interested in engineering. And so when I got into knife making, I picked up a copy of John Verhoeven's book. Read that thing like 4 times in 8th grade, trying to sort out what it all meant. And that kind of caught my interest in steels. And since then, I've been trying to kind of push the limits using a lot of steels that you don't really see in kitchen knives because they're hard to grind, hard to finish, that sort of thing. And just messing around, seeing what I can come up with.
What steels are we talking about here?
Yeah, so I mean, it ranges from, pretty mundane things like AEBL, and for those, I'll develop a heat treatment that I like and really dial it in, heat treatment coupons, that sort of thing, to, the more exotic stuff like Van Kron Super Clean, probably the most exotic thing I've worked. But it's the sort of stuff that you really need to go out there to source, the sort of stuff you can't just like buy off of some online retailer.
Now, how do you source such exotic things?
Mostly I have a couple of contacts at the companies that make this stuff. So I don't know how you pronounce their name. Voestalpine. Their sales reps are super useful.
It's an Austrian company, Voestalpine.
Yeah, there you go. I basically nailed it then. That's pretty good.
Close, yeah.
I should know because they sponsor our research center here. So, but yeah, basically you reach out to them. If you're really nice and you get them on the right day, they'll try to help you out with some stuff. But mostly it's expensive. Like at the end of the day, when you're sourcing some of this stuff, it is just really expensive for the material. So like, for some things I can easily end up paying like close to Damasteel prices for monosteel. But I mean, at the end of the day, it's not a huge, materials costs are not actually the main costs in knife making for the stuff that you sell. So it's not a huge deal.
Yeah, but Damasteel prices are...
Yeah, it's pretty expensive.
You are hitting it. And I guess you really need to kind of find those customers that know these exotic steels, and I think you are doing a great thing about educating people on steels and actually showcasing them, right? With your website, with what you did in posting when you used to post at least a little bit more, and that really gets people into it. Whoa, I've never seen that steel. That's really interesting,
Yeah, I mean, it's kind of it goes both ways, because then also I have some friends who are knife makers, and every once in a while they'll get one of these like really steel nerd people come up to them and say, "Can you make a knife in this steel?" I'm like, no, but I know who can, and so a lot of the times it'll get sent my way. And the nice thing is that I don't make enough knives per year to really hit the edge of what my customer base is. So there are a lot more people who are interested in my knives than I have time to make knives for the foreseeable future. So I'm all set there. Mostly it's just a matter of, getting time to make these things.
Just talking about metallurgy and steels in general, because you started knife making so young, right?
Yep.
It kind of looks like, because you're doing a PhD in metallurgy, kind of the knives had a very big influence on where you are headed, or you were interested in metallurgy first and then you started knife making and you're like, this kind of rocks.
Oh yeah, I mean, absolutely. The knives are. I knew I wanted to be an engineer since I was like 6 years old or something crazy like that. But that was like the moment where I was like, I know what sort of engineer I want to be. And that's how I ended up here. I went and did my undergrad in Pittsburgh, studying material science and engineering to kind of broaden out and like learn more of the basics about all sorts of material systems. ended up doing undergraduate research there with a professor who worked with steel. And I, in that time, I read Laren's book. Laren Thomas is out in Pittsburgh. We chatted a couple times. And yeah, basically he was like, okay, you know what you should do? You should go to Colorado School of Mines because it's the only place to go. And it is. If you want to do steel metallurgy, it's really the only big graduate program in the country that has that as an option.
Colorado School of Mines doesn't sound fun.
It's great. The children yearn for the mines.
Hard work, hard labor, small hands, small wages.
Absolutely. They can get their hands stick the dynamite into the holes more easily.
Perfect. But you said that you first went to material science, right?
Yeah.
And I have no idea what goes into that, but did that help with your knife making? Did you learn something that you saw like other knife makers? Yeah, like you are full of shit. The science is totally different.
Yeah, I mean, not so much through the program. I'm big into like learning things on my own, reading about things, whatever. I went on eBay and bought a whole bunch of books on steel metallurgy and read them. And honestly, they're pretty clear about what you should and shouldn't do. And it's a lot of the knowledge is already out there. A lot of my personal role in that knowledge in the knife making community is hopefully just translating. Like even I haven't posted. I haven't really posted in 2 years until recently. I'm back into knife making finally. It's wonderful. I should have some more consistent sort of stuff in the future. But even during that time, I would get DMs, once a week or so, with people asking about heat treatment questions and that sort of thing. And it's really just translating. Like all I am is a translator. I've read the books. I know what's going on. A lot of the problems that people have aren't, super duper complicated. It's just getting the knowledge to the right person.
You are basically ChatGPT for them. And
yeah, basically.
Like, simplify.
There you go.
Simplify this for me.
Yeah, exactly.
Yeah. But does the material science, kind of what you learned, does it include, could you explain, is hidden tang better than full tang or whatever? Or does that not kind of include that?
Sure. So metallurgy is the study of metals. Material science is the study of materials. So metallurgy is included in there. The point of the material science program is that it also teaches you things about like composite materials, semiconductors, ceramics, polymers, all that sort of stuff. So it's a much broader program. We don't do a ton of mechanical engineering, which is what you would be talking about. I did take mechanical engineering courses, but I wouldn't say it's like my specific strong suit. There's some basic engineering stuff you can go into for like full tang versus hidden tang and strength. But I wouldn't say I have particular expertise in that.
But when you said synthetics and ceramics, instantly thought G10, micarta, ceramic belts.
Yeah, like that's something I would know about. Yeah, for sure.
Oh, okay. That's interesting to hear. But like then you learn how to work with those materials or how they behave and what to expect or
Yep, exactly. I mean, I think the main things is how they behave, their tensile properties, how they fracture and fail, how they're made, that sort of thing.
Oh, that's extremely interesting because then you have more in-depth knowledge about the materials that you would like to choose.
You could write an entire book, like Laren has his Knife Steel Nerds book. You could write an entire book about abrasives too for knife makers, like how to select abrasives, what they do, what all the industry lingo means, because that entire industry is like, I don't know what the belts I'm buying are necessarily. Like they're ceramic. I know roughly what the abrasive compounds are, but they don't really have details on there. Right. I know they're alumina based ceramics. I know stuff like that, but they don't like readily publish all this stuff about what specifically it is. It's like if you went to like Alpha Knife Supply and you could buy carbon steel, stainless steel, or alloy steel, and that's the names they gave you. They didn't give you any other details. That's it.
Yeah.
That's kind of how we end up buying a lot of abrasives. But I'm sure that you could optimize all this stuff quite a bit more.
at least some belt manufacturers state the purpose. Is it like high pressure, high speed, slow speed? Like
Sure.
that at least helps a little bit. Do you like a simple question?
Yeah.
Do you have a favorite belt that is ceramic?
Do I have a favorite belt?
Yeah.
I mean, it depends on the purpose, a lot on the purpose. I really like the blue 36 grit Actoric, whatever they're called, belts.
Actorox, yeah, VSM.
Yeah. I really like those belts. They have very mixed reviews from knife makers. One thing that you really need to understand about all these ceramic belts is that you're always fighting a battle between glazing your belt, which is where the abrasives get kind of rounded out and aren't really cutting, and keeping your belt fracturing at the right rate. And so a lot of these belts, they're designed to have a certain amount of force put on them. They need that force in order to fracture. Otherwise, you glaze the belt over and it doesn't really work. My biggest change that I made at my grinding procedure, which really made those belts my personal choice, is I went to full water cooled, not Mr. cooled, but like a full pump water setup. So I have, about as much cooling as I can possibly get. And that means that I can really turn up those belt speeds and put enough pressure on belts that they degrade like they're meant to, even when you have large contact areas with the belt.
Oh, that's very interesting because
the smaller your contact area, like, some people find belts and they're like, oh, this works really well for profiling, but I can't bevel with it. That's because when you bevel, your contact area with the belt is much higher and the force you're putting on is the same. So the pressure on the abrasive particles is too low to actually fracture them. Whereas when you profile, your contact area is very small. And so if you put the same amount of force on, you get a lot more pressure and your abrasive is actually properly degrading the way it's meant to.
So especially if grinding chef's knives, the surface area is increasing exponentially, like really quickly, then you need to up the pressure, or maybe you can dial down the speed then and leave the same pressure. Or
dialing down the speed doesn't actually help you fracture the abrasive better. You need to find a way to get the correct combination of pressure on there.
Just pressure.
Yeah, I mean, there are things that you can do. People dress their belts. You can take a piece of hardened steel. I've seen some people use a diamond. I've never tried that before, but it should work. And run your belt up to a nice high speed and jam it in there to refracture the abrasive. That's something I use. If I glaze a belt over, I have a piece of, I think it's just like quenched 1095 or something like that. I just jam it in there nice and hard to refracture the abrasive. And that's pretty good. You'll definitely see, if you look at the surface of your knife, right, when the belt's glazed, your surface starts getting shiny. And once you do that, you'll see that it goes dull again, at least for a little while until it reglazes.
And is it like the same, like the glazing, right? Is it the same working mechanism in the background as if you are using like structured abrasives, or like, if I remember correctly, it's agglomerate with like the clumps of aluminum oxide, and they stop cutting?
I don't know off the top of my head. There's a difference. Glazing is not necessarily a technical term. I think it just refers to, I at least conceptualize it, is just referring to when your belt stops cutting, but there's abrasive left. But you could break that down even further into, okay, my belt could be glazing because I have some softer compound that's loading up everything. And that could be either a compound that's in the belt already, waxes or oils from wood or something like that. That would do it. It could also be, if you grind a lot of like high alloy steels, something with vanadium carbides or niobium carbides, those are both harder than your abrasive. So your knife could be abrading your belt and wearing everything smooth at a faster rate than your belt is abrading your knife. And that's how you get these belts that just don't cut. They look fine, but they don't cut because the abrasive is all rounded out. Or you could have something that's a combination of those two, where you get a little bit of wear and a little bit of loading. I would assume it depends. Again, that's probably beyond my expertise.
Yeah, but that's some great knowledge. I mean, I really wanted, you are a professional, you are doing a PhD in this field, getting the answers, because you would not believe, but me and Benjamin come on 4 hours in the DMs, we both don't know the shit we are talking about, and we are like, no, you are wrong, no, you are wrong, and you know almost all the facts. So good to have that clear.
So I have a question though, maybe for like some of our newer knife maker listeners, would it be true for them if they're kind of unsure with their grinding style and maybe not putting enough force on the belt yet because they're a little bit unsure, that buying these expensive belts really aren't helping them at all? Would there be a better belt for a new knife maker like that?
I don't know off the top of my head, but I would say, like, especially if you're unsure, you're not getting as much out of these ceramic belts as the expensive ceramic belts, especially if you aren't breaking down those compounds. At the end of the day, I find that a lot of grinding is just like technique, and that you're getting better belts doesn't necessarily make you grind particularly faster. You just end up wasting more belt and more money.
That's exactly what the Wisam technician we had at our shop told us, that most a lot of knife makers use the wrong belts that are meant for high pressure and like machine finishes. But they spend like shitloads of money on belts that are too expensive what they are using them for, right? So usually some belts need a lot of pressure, and when you're grinding, let's say you're freehand grinding your knife, you can't apply that amount of pressure you're supposed to in order to break the ceramics in the way you wanted it to break. So people spend too much money on belts that are too expensive for what they're doing. That's what this guy told us. Because some shops sell these high pressure belts to like normal knife makers, and what they do is like use a push stick method of do like freehand grinding on the belt grinder, and they never can break the brace if it's supposed to break, right? So
I mean I think specifically there are a few brands that I think people especially run into trouble with. I don't remember the numbers off the top of my head, but for like the Cubitron belts, there are a number of different versions of them that are meant for different pressures. And so like figuring out when you buy them exactly which Cubitron belt you're buying it's a huge difference. Like some of those belts, they just don't work. I have for hand grinding, I have one of those surface grinder attachments, and for those there's a different type of belt I use, a different type of 36 grit belt. And so that's the sort of thing that you should be looking for in those.
So with like all this belt talk that you've obviously gone into trying to find the right belt for maybe some of these exotic steels, is that kind of what got you into learning more about these belts here, or
absolutely. They're brutal and awful to grind.
Okay.
It is not fun, and I grind from full thickness. Like I heat treat at full thickness because I really, really don't like warping. And I just so that's the way I do it. So I'm removing a whole bunch of hardened material. I also they're not, it depends on the kitchen knife maker, but most kitchen knife makers start from pretty thin stock, especially people who are starting out. I found that actually going from thicker stock is more what people want. And you do a lot of distal taper. So basically I start by surface grinding in a distal taper. And then from there, I'll grind in a first bevel, and then I'll grind in a bevel at a higher angle, and then blend those two bevels to get kind of a convex geometry. And so, you're taking at the tip, I'm going from, let's get this in millimeters for you guys. Starting at 4.5 millimeters or so at the spine, and it usually stays there at the very spine where you grab. Gives you a nice substantial feel in the hand. 4.5, sometimes even a little bit more than that. And then out at the tip, it's more like, I got this.
Google Foo.
Google. Yeah. 1.5 millimeters. And so, at the tip, you're removing like 3 millimeters of hardened steel, which is, that's a good amount of material to remove. And so just really optimizing my process to remove that somewhat efficiently. That was a big part of it. And then just trying to get better surface finishes before I have to start going to like hand sanding stages and stuff like that is huge.
Yeah, working with thick stock like that makes sense that you work with like a fully cooled grinding system.
Yeah, definitely. That helps a lot. Something I want to get into more that I have been experimenting with now to alleviate a lot of this is just forging. Is just taking that material and forging it down, and it's been great so far. It cuts the amount of stock removal time I do significantly, and for a steel like AEBL or even some of the low alloy stuff like Apex Ultra or whatever, you're not cutting down that much grinding time, so forging isn't necessarily an economical thing. But for, when you start getting up there into like your K390 or 10V, that sort of stuff, forging it out first is like huge. It saves you abrasive costs. It saves you time grinding, like a lot of time grinding in most cases. And you still do have to worry about like warping a little bit, but it's just at that point it's worth it. Whereas if you're pre-grinding, you're still, removing material and you're losing on material cost.
Just a little bit back to the belt talk.
Yep.
When you are working, let's say, with some simple stainlesses like ABL and then
Yep.
something that is extremely high alloyed,
Yep.
do you use the same belt
Yeah,
for grinding?
I use the same belts regardless. The only thing that I change belts for is if I'm grinding something that's sanmai, where you have those soft layers on the outside. Oftentimes, there's some different tricks you can use for that. Personally, my favorite one is I just start at a higher grit. Like when I'm grinding a sanmai knife, I start at 600 grit, or sorry, 60 grit, 600.
And then continuing with the finishing of the blade, right? If you want to get a very great surface finish, and some steels like Magna Cut, I heard, is very hard to hand sand, and it's extremely hard to get a very consistent belt finish on it. Do you have like some tips and tricks how to get that?
Yeah, sure. First, I mean, with Magna Cut, I don't think Magna Cut gets, in my opinion, a particularly poor reputation for these things, mostly because it's a lot of people messing with Magna Cut who don't mess with these steels normally. Magna Cut finishes extremely easily compared to a lot of other high alloy, even PM steels, just because the carbides are nice and fine, which keeps everything in check. But you are always fighting the battle. Whenever you pick up a steel which has high enough vanadium content, you're always fighting the battle that your carbides are now harder than your abrasive particle. And so at high grits, low grits, high abrasive particle size, your abrasive particles can hit those carbides and fracture them and then pull them out, or scoop out the matrix around them and then remove them. It's the specifically what's going on there is a little difficult to tell. There's a field of study called tribology, which is studying how wear like that occurs. And you could I'm sure you could go to a tribology conference and get into a fist fight over exactly how this happens. I'm sure those people are very passionate. Luckily, I don't have to deal with that too much. But as your particles get smaller, they can no longer fracture or scoop out the matrix. And so the carbide just sit there. And the moment your particle passes over the carbide, it fractures and falls off and your sandpaper goes dead. So my tips for Magna Cut are the very, very worst tip of all time that all makers are going to hate: use diamonds. Like get diamond lapping films. It solves the problem. Your Magna Cut polishes like AEBL. Done. Problem solved. The problem is that they're expensive. I think that most makers, if they were truthful with themselves and did the math, would find that the diamonds are still worth it. because of the time you save. But it's just hard to convince people to do that sort of thing. And there are not that many people who supply good diamond products that are easy to find. Beyond that, start at a lower grit. Start at 120 instead of 220 to really make sure that you're not fighting scratches as hard. Go to like 3. So we usually, I don't know about you guys, when I take my J hooks out on like a ABL, right? I'll sand to 400, I'll sand to 600, and then I'll do straight passes. With something like MagnaCut, I'm doing straight passes at 320 grit, and then I'm going up to 600 grit, doing my whole hand sanding procedure, and then I'm doing straight passes again. Because if you have J hooks at 220 grit or 120 grit, you are not going to be able to get them out with 600 in any sort of fast process.
Oh, that's a good tip. But if you are talking about high vanadium steels, I don't know, maybe M390, I guess, or LMAX or whatever.
Yeah, those aren't too bad. Those only have a very small percentage of vanadium carbides because most of it goes into the chromium carbides.
But if you have like a high vanadium steel,
yeah,
I cannot name any off the top of my head, but let's imagine, right? Would you suggest that you need to stop on the grinder? You shouldn't go above as your ceramic belts go. So you shouldn't go to like 220 aluminous oxide or 400 aluminous oxide belts.
No, those are fine.
Those are fine? Wouldn't they... isn't there the issue that you said about removing the matrix and not hitting the carbides, and then you have like a wonky finish?
Oh, that's not going to be a primary issue there. That's not what's going to lead to the wonky finish. That's just going to lead to your abrasive particles wearing down fast and you getting scratches that you can't really get out. I would still go as high as you normally do on your machines. Just it takes a while, and at some point you're going to be there on a 220 grit belt and be like, this isn't doing anything and this belt is already dead. And that's where you need to make the judgment call, because sandpaper is cheaper than belts usually. You will be wearing through your belts as quickly as you wear through your sandpaper. Something I've wanted to look into for these sorts of things. Well, the other thing I do is that I have diamond stones for sharpening. But then I'll take those stones, and before I hand polish, I'll go through and get out all of the belt grinder scratches on the diamond stone. I take a 400 grit stone. I do the entire surface. Just like I don't know if any of you guys have thinned a kitchen knife on a stone by hand, but it's that same process. You go through on the bevel and you hit everything until those scratches are gone. And that sets me up with a 400 grit stone finish that I can go back and do 220 by hand. And that cuts the time way down as well.
But it sounds really great if you have like a outside geometry, like a flat grind or a convex. But if you have anything concave,
you're cooked.
You're hella cooked. But instead of using the diamond abrasives, I guess these are ceramic stones, so they are the same. Like I forget the brand name, but borite, I guess, or
something like that.
Yeah. I think borite is also still. They brand them. I believe they brand them like they're not a aluminum oxide abrasive, but I'm pretty sure they're aluminum oxide.
So they are no good. They're the same as paper.
They're fine. The advantage you get out of the boride stones is that you're continuously refreshing your abrasive, right? With sandpaper, what happens is that your abrasive on that piece of paper gets worn down or fractured or whatever and isn't cutting anymore, and you're done. With stones, with like die maker stones of all those varieties, you are continuously getting fresh abrasive, which can be nice. I personally don't use them because I have trouble getting like really nice flat finishes, because since your contact area is relatively small, you can end up getting waves in your finishes, and that drives me nuts. So I don't do that. Maybe if I were more skilled at grinding, I wouldn't have that problem. But it is the way. So I wouldn't say those necessarily represent a huge difference. The big one for me is just diamonds. Diamonds or cubic boron nitride, just it changes everything.
I guess you can have like sticks with radius made with CBN.
Yeah, absolutely. Yeah.
But I guess it wears out hella quick also, especially high grit.
Yeah, for high, I mean, depends on how high you want to go.
As high as possible. Don't want to use that paper.
Got it. I mean, I only go up to like 600 usually for those sorts of finishes, 600 grit straight passes. But it's just, it's important to keep your abrasive nice and fresh. Depending on your particular binding agent, like how you bind it to it, is it vitrified? Is it one of those electrolytically bound?
Electroplated, right?
Electroplated, there you go. Those are going to wear very differently, and that sort of thing really matters. Or resin bond.
Yeah.
All those things are going to change a lot how your abrasive wears for those sorts of things, but they're definitely the ideal way to polish those steels if you can.
And like the resin bonded, like I looked at wheels for sharpening, and I talked to Dr. Marv about it, and read his blog. And apparently, I did not knew that, but it's kind of the same as with the belts, because there are different mixtures of resin bonded, like wheels or sticks, with different additives, which would one benefit with higher speed, higher pressure. Sometimes other are lower pressure and faster cutting. So you need to keep your eyes open when you are trying to purchase something like really custom made.
Yeah, definitely. I mean, when I sharpen on diamond stones by hand, but it's it's the same thing where like not all diamond stones are created equal, and they're all different binding agents, and they all are going to have different properties.
And I guess different lubricants you need to use. Like with the stones, some like oil, some like water, maybe some else. If it is electroplated, maybe you can get away without using any, but something is better than nothing.
Yeah, definitely.
So with like all these like super steels and things that you're working with, and you talked about the different qualities of belts and stuff like that, how important would, like, I don't know, you just pick MagnaCut as an example, how important is like the heat treating process on a steel like that? Because a lot of people, or buyers at least, are buying the name of the steel, and maybe that steel is not getting the best heat treat possible.
Yeah, I don't know. I have maybe a controversial take on heat treatment. As a metallurgist, and it's just that you can train a monkey to heat treat. At the end of the day, it's not, heat treating is not necessarily the black magic that some people make it out to be. Follow the books, control your temperatures, use the right quenchant, use the right tempering temperatures in a controlled environment. You're done. It is not anything crazy. Where people get into trouble is when they, go off of those recommendations or aren't controlling their environment. And there are all sorts of things you can do to really optimize heat treatments. But at the end of the day, like people talk about how like, oh yeah, steel choice doesn't really matter. Geometry is what matters. Well, what matters even less than steel choice and geometry are the exact variety of particular heat treatment steps you do, kind of that last little bit of performance you squeeze out between a 90% good heat treatment and the best heat treatment in the world is like 2%, 1%. It's a very small difference there. Now, there are all sorts of things that could go wrong, and if you have a truly bad heat treatment, if I take my MagnaCut and heat it up in a forge and quench it in oil, well, then of course it's going to be awful. It's not going to be great. But one of the really great things about high alloy steels, once you have enough alloy in there that you're no longer, racing in your quench, like with 1095 or whatever, is just the failure modes are so much less extreme. Like you can't quench magna cut slowly enough in your shop that you get perlite. Unless you're doing something ridiculously silly. If you pull that thing out of your forge, leave it on the table, it'll be fully martensite. You might have a teeny tiny bit more retained austenite than if you quenched it faster, but you're really looking at the last little bits here. And so I just you can do it. You need to be controlling variables. I recommend having a hardness tester so that you can actually make sure you're doing things right and check that sort of thing. But if you're taking your knife, you're following the directions that either Laren wrote or some manufacturer wrote or something like that, and you're getting hardnesses that make sense, that are about what are expected, your heat treatment's fine. Could you optimize it more? Could you be getting very slightly more or less retained austenite to get the perfect properties? Yeah, sure, blah, blah, blah. At the end of the day, that's a small difference.
Yeah, excellent. I'm gonna clip this 100%, but you mentioned a really important point, which is verification. And Ryan DM'd me because some guy was giving him shit under the reel, and he said to me, what would you prefer, for heat treatment, a forge or a kiln? And I said, it does not matter if you don't do verification, if you do not look at what hardness you are getting. It does not matter. If your kiln can be off too, and if you are doing something by eye, maybe in that case, even doing something by eye, you have actual verification. The color, that you need to hit. But in the kiln, only when you open it and you're like, maybe that's okay, I need to do the quench. And then you can have a very bad experience too, And
Sure. I mean, the thing I would add to that is that unfortunately, with heat treating in a forge, you're almost always heat treating steels that I would call hard to heat treat. Like people recommend 1095 and whatever to beginners. Those are super hard to heat treat. Those are freaking, you need one particular temperature within like 25 degrees Fahrenheit, so like 10 degrees Celsius or so, or else your properties are even worse than they started with. I mean, 1095 is not an extremely great performer to begin with, but you have a tiny little range of acceptable austenization temperatures, and if you austenize too hot, there's nothing in there to keep your grain fine, so your grain explodes, and then you quench it. And you have to quench it super duper fast, otherwise you get perlite. And even if you pull out of the quench and you like poke like 64 HRC or something out of the quench for 1095, 64 HRC, you probably have perlite in there. And so it looks fine, but your edge performance is just not going to be good because you have this soft phase.
Such a great take. And you also mentioned before that you are doing a little bit of forging, like doing the distal taper.
Yeah.
And if you are working with like high-end steels, K390 or something like that,
yep.
Do you usually, I guess, you forge out of a kiln?
It depends. I've actually experimented with both. I generally just forge out of a forge, and the temperatures are, there's some tricks to it. The hardest part about these steels is that they're really hard under the hammer. And the first thing a blacksmith will do if they feel something is hard on the hammer is heat it up more. The problem is that these steels are such high alloy, they're hot short, which is when your steel crumbles because it starts to liquefy. And so you just need to deal with the fact that they're going to be that way. The wonderful thing about really high vanadium steels, forging them, is that you don't really need to worry about messing anything up. Like the vanadium diffusion rates at those temperatures are still slow. Your carbides don't have time to coarsen particularly significantly in the times you have. You can, run the diffusion calculations if you really wanted to experience that joy. But they really are quite tolerant to the temperatures you're working with because of that. And you don't get things like carbides that reprecipitate on your grain boundaries in long strings as much because of that diffusion. There's some things you want to be careful with. I'm lucky that I can, do metallurgy, so I can I forge something out. I'll cut a piece off. I'll I'll polish and etch it and look at the microstructure and make sure it looks good. But in most times it's just there's no change. Like there's no real observable change.
And talking about forging and heat treatment and kilns, I need to give way to our sponsor. Kilns. This show is sponsored by minihell.eu. Wonderful, great, amazing kilns made in Poland. Excellent quality, super affordable. I have one for like 5, 4, maybe 6 years. Nothing changed. And it's easy, super easy to maintain. Baltazar, when we did the show with minihell.eu, he said it takes only like 20 minutes to repair your kiln, which is it's a maintenance thing. And you have new bricks inside, new coils. Easy peasy. 20 minutes, imagine it, and brand new kiln. Also, when you are shopping on minihell.eu, please do remember, use carbon 5 at checkout so Baltazar knows that you came from us, and also you save a whole 5% on already affordable kiln, and you maybe can spend it on some fancy steel. And while you are shopping on there, look at wonderful racks made by Baltazar for batch hardening for super simple carbon steels, and heat treatment foil, because you will need that for your stainless steel hardening. So minihell.eu. And now, my lads, back to the show. I did not have any backup question after that.
I got one about the 1095. I think maybe, just starting out, it's really hard and super confusing if you don't know anything about steel. Reading all the, you get different temperature recommendations, all over the place over the internet. I think maybe that's why 1095, because you said, you hit this one temperature and everybody says it's good. A lot of the other steels, there's such a huge variation in what you find online. And I think it might have to do with the recommendation from the manufacturer, starting with a 2-inch crosscut or something like that. And you, as a knife maker, you're working with thinner steels. So for the holding times and stuff are difficult.
Yeah. I mean, I just think that 1095 is 1095 is my favorite steel to rag on, because it doesn't really have anything going for it. It
got Hammonds. You can make a Hamon really, really good on it, right?
Yeah, but you could do that with like W2 or something and get a better one. You get it's better aesthetically. It's better for everything. The problem that you really run into with 1095 is there's nothing to keep carbon out of solution. And so you just end up getting a whole bunch of, martensite forms in 2 different forms. You get lath martensite, which is the martensite that generally has good properties, and plate martensite, which generally has bad properties. There's a lot more complexity behind it than I think maybe a lot of people go into, but that's a good general overview. 1095 has so much carbon in solution that you pretty much always get plate martensite, and it has, as a result, very poor toughness for its hardness and strength. And so you can go with any number of other things and just get better results. The one I go to for beginners, like beginner who wants to heat treat out of a forge, out of whatever, 80 CRV2. Laren wrote a great article about this, and I think I was chatting with him once. I think we were texting or something. I was like, yeah, so I did this 80 CRV2 experiments, and they're pretty interesting. And I concluded that basically it doesn't matter. You can do whatever you want, and it's kind of fine. There's something to be said for that. It's just it has lower carbon content, so you have less risk of plate martensite formation. There's some chromium in there, which helps to keep your carbon out of solution. The vanadium pins the grains, so your grains don't explode if you overheat it. And so it's a really great, and I'd highly recommend anyone look up his article on this and read it, but you essentially get good properties over a pretty large range of temperatures, which for me, you're heat treating out of forge, that'll be the steel that I would pick.
For me, I used to work with 80 CRV2. If I remember correctly, it has a soak time of 10 minutes or something like that, the temperature. And it kind of, then you have to deal with decarb.
So soak times are a time temperature related thing. So if you heat up hotter, your soak time goes down. And generally, when you heat treat in a forge, I mean, you can I'll just pick something off the top of my head. I was working on a curve on this, and I never had time to quite finish it. If I, for example, and this is not correct in exact numbers, but it'll give you the idea. If I take AEBL and austenitize it at 1025 C, right, for 1 hour, and then I take the same AEBL and austenitize it at 1035 C for 30 minutes and quench them, they might come out at the same hardness, because your soak time, most of these steels, most of the time, we're not actually soaking the steels long enough that they reach their equilibrium point. We're approaching that, but we don't reach it. And so for something like ADCRV2, if you're heat treating in a forge, people very often will overheat and then underheat and then overheat and then underheat. But the thing is, your carbon doesn't go back in solution when you underheat it. It doesn't, or back into carbides when you underheat it, particularly, because you're still below you still haven't reached your equilibrium point. And so every time you overheat it a little bit, you're jumping way ahead in your soak time effectively. And so your soak times just don't need to be as long when you're heat treating out of a forge, if you're overheating like that. Now, if somehow you are, have the best eyes in the world and can tell the difference between 15 degrees Celsius just by your eyeball looking into the forge, I can't do that, but I'm sure somebody out there can, or definitely claims they can. If you take that and you're heat treating at exactly the right temperatures, then yeah, you might run into a problem that you're not soaking for long enough. But generally, you can get away with just going a little bit hotter and then soaking less long.
Never thought about it, but makes perfectly sense. And I think I never thought about it because if you look at the data sheets that the manufacturers provide, let's go to Elmax or something like that again, they give it the recommended soak time and the temperature range, but they are kind of separate, and the soak time is kind of tied in together with the thickness of the actual stock. Yep. And I never thought that if you hit the upper limit of the temperatures, that the soak time for the same cross section is actually lower. But it makes perfect sense when you put it like that.
So manufacturers tend to do it that way because they're trying to adjust your soak time for your thickness, right? For heat transfer to occur through to the center of your workpiece. For knives, we don't have to consider that. If you look at the heat transfer kinetics, heat at the surface of your knife is essentially the same as the heat in the center of your knife, unless your heating rates are extremely high somehow. The heat transfer, like if you think about how quickly metals conduct heat, the heat transfer is so fast in our little tiny knives that it's just not a big deal.
Oh, another question. Oh, so good that I remembered. Let's say I'm working with Elmax, right? They are saying like you need to soak for like 30 minutes or something like that, and at 1160 C, right?
Yep.
What if, right? I have like 3 millimeters, like almost 4 millimeters of stock, but I do pre-grinds, and the cross section at the edge is way smaller, right? Do I need the full soak time or not?
It depends on why you're soaking for. So I would argue that your steel, once it gets up to temperature, you can make a graph. I think I probably have a graph posted on my blog somewhere of like the heat treatment of the temperature, the heating rate of a steel after you put it into your furnace at the surface and inside. Once your surface is up to temperature, your core of your steel is pretty much up to temperature. It lags behind by a tiny bit, but it's hardly anything at all. Just because the rate that you can get heat to the surface of the steel is so much higher than so much lower than the rate that the heat transfers a few millimeters in steel. So I wouldn't worry about that part first. On the soak time, soak times are something that you can, do you have a hardness tester?
Yes.
Okay, perfect. Soak times are something that are easy to mess with because all you need to do is pick your austenitization temperature, keep that constant, run a set of coupons at different soak times, pull them out, quench them, and look at the hardnesses you're getting, right? And then just pick the hardness you want. It's that simple. There's not...
Because maybe I was overthinking it, because if you do pre-grinds, right, and you go to like on the edges, like 0.8 millimeters, let's say, and your spine is like 3.5 or maybe more millimeters. And I'm like, how does it go into the solution? You know, do I need to do like, does it need to be heated fully? But you say the heat transfer speed is almost the same. You know, it will be heated fully to the core.
It's pretty similar. It is at least within a couple minutes. It's definitely not like 10 minutes. It is going to be quite similar. Oh, I would just take a look at those soak times. There's some things you want to stay away from. You won't want to do extremely low soak times, because then you're not going to get the right alloy in solution, essentially. But if I'm trying to choose between, like, I run these curves too. I do 2 curves usually. I do a curve that's my I keep my austenization temperature the same, and then change the soak time. And then I do a second one where I keep the soak time the same after I pick a soak time, and then check the austenization temperature. As long as you're not at the extreme ends of those 2 curves, you're fine. I mean, it's one of those things that you're making small trade-offs. If you keep your austenization temperature hotter and soak for a lot less long, then you can risk having uneven heat transfer. Whereas if you do it the other way around, you're just spending a lot more time at temperature. You're risking decarb and all sorts of other issues. And so usually what you want to do is you want to pick it such that you're soaking for between 15 and 30 minutes at a appropriate temperature to reach the properties that you want. And as long as you're not over the hump, as long as you're not heat treating where your hardness starts to go down again from high temperature, you're fine.
So much knowledge. I have another question because it's so interesting. Maybe Albert will want to jump in after this one, but I don't know. I will let you talk. If I understand correctly, you mentioned that you were working on a curve on the website for how quickly the heat transfers from the kiln when you just put it in, right, to the blade. What I do, and please correct me if I am doing it wrong, right?
Yep.
I just open my kiln. It's a temperature that's the soak temperature. Yep. I put in my blades.
Yep.
I close the door.
Yep.
Naturally, the temperature drops down, and I wait until the temperature in the kiln controller shows the expected temperature, and then I start the timer for the soaking time.
Yep. So that's exactly how I do it. That doesn't mean that your blade is actually heated up in that time. The reason why you do it that way is just that you're doing it consistently. Your furnace is pretty much, regardless of everything, going to take roughly the same amount of time to heat up, back up once you've lost heat. And since you're doing it consistently, and if you've done your own heat treatment curves and did your curves that way, then you'll just match the curves and you're fine. So that's how I do it. It's just that you have a consistent offset. Now you could do all sorts of complicated things and wire up thermocouples and blah, 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 and figure out exactly when your knife is heated. But it's probably only a minute or 2 difference, and that's not going to be significant. The important part about heat treating is that you find the heat treatment that works and you have it repeatable. You do the same things every time, and that's how you avoid problems. It wouldn't matter, if your knives, if you did that and then waited another 3 minutes and then made your curves based off of that, great. Your curves would just be offset from mine by 3 minutes or something like that. That doesn't matter. As long as you've actually hardness tested everything and found the heat treatment that works, you're good. That's fine.
Makes perfect sense. And as what I gathered, the most important part is having a hardness tester, just having the verification so you can just know actually what you are doing. No, don't take your knife and try to scratch a bottle and say, oh yeah, it's hard, it cuts the glass. You have no idea.
No.
And it's even more important because even if you do have a kiln, I think the chamber size is really important because you can have a huge kiln which takes way longer to go back up to the temperatures to calculate your soak time. And you can have a very small one meant for EDCs, and it will be way, way quicker.
Yeah. And of course, standard metallurgist disclaimer that hardness isn't everything. It's not like a 160 HRC knife is not the same as the other, even if they're the same steels. You can have different microstructures, different retained austenite amounts, but within reason, those are mostly going to be the same in terms of performance. You can go to the extremes. Like you can, of course, take your MagnaCut, austenitize it 100 degrees above the manufacturer recommended temperature, get 30% retained austenite, but still have 60 HRC and have bad performance. But most people's cases don't fall that extreme. Most of the time, we're on the right side of the curve, and it's just a question of, okay, your heat treatment has slightly more retained austenite than mine. Well, is that good or bad for properties? That's a discussion to be had. Exactly.
And sorry, Albert, I just have so many questions. Just continuing about the steel talk, as far as I understand, if you do kitchen knives, it's not only the hardness, as you said, is really important, but also the edge stability, which comes from like microscopic toughness. And you mentioned that you worked with really, really exotic steels, that are pretty hard to get. Is there a steel that you really wanted to get but haven't laid your hands on yet?
What am I looking for?
Grail steel that you really want but you can't get.
Not really anything. They're just, unfortunately, we unfortunately live in excellent times, and Laren's new steels have kind of destroyed a lot of the interesting steels market because they're just better. Like MagnaCut, I think I wrote about this somewhere. MagnaCut made a whole bunch of steels in my mind, almost entirely irrelevant. There's almost no reason to use 4V anymore. Why would I use 4V when I can just use MagnaCut and get stainless on top of everything? There, done. Why would I use like Crewforge V Crewware when I could just use MagnaCut and also have stainless on top of everything? Done. And there are a whole list of these steels, and now with Magna Max, it's kind of the same thing of like, why would I use 10V? Unless I'm going to really high hardness, there's not a lot of reason to use it. And it's kind of really changed the market in a lot of ways. So there were some steels I was interested in before that now it's like, I don't know. Well, I was looking for some powder metallurgy T15 for a while. I got some small pieces and made some knives, and they were pretty good. But now Magnamax exists, and it's like, why am I bothering with that?
But there is still a reason to maybe bother with Vacron Super Clean?
No, not really. I mean,
not really.
It depends on, I would say for 99% of users, no. Vacron is a very niche steel. It has one purpose, and that's to hit really high hardness and form really fine edges. For most people, that's not a huge thing, and they won't even notice. For some, extremely knife steel nerdy sort of people, they'll enjoy that. But the wear resistance is fine. It's not excellent. It's like CPM M4. Basically, Vacron Super Clean is CPM M4, if you know that one, with finer carbides, and it polishes slightly easier and better. That's it. Nothing crazy. And I think it has slightly better toughness at high hardness.
And if you are making a kitchen knife, that is really important, high hardness. I don't think that and maybe you can correct me, that the wear resistance is that extremely important because the geometry actually does the cutting, maybe. And if you have like high hardness, high toughness, you can do a very, very fine edge with cuts really, really well. That does actually the cutting.
It depends on what you're cutting.
Yeah,
that's always the answer. I mean, if you're out there processing a whole bunch of lemongrass every day, I think that's the one. That's super abrasive, then yeah, your wear resistance is going to be what you run into. I think the thing that people forget is that everything we eat, or a lot of things we eat, leafy greens and such, they're full of silica. They have a bunch of silica in there. It's abrasive. And for kitchen knife edges, the space you have between a very sharp edge and a pretty dull edge is small because your edge geometry is, because everything is so fine, and because I might want to go ahead and slice something that's, pretty, like tomato skins or whatever right after that, that's pretty sensitive to sharpness. And so wear resistance can be helpful. But for most people, no, I think, MagnaCut roughly strikes the right balance. It's stainless too. Like, thing that people forget is I can't see corrosion on my blade, but corrosion is highly dependent on geometry. Really fine surfaces, really sharp surfaces will corrode faster because they have high surface energy. And so if I go and cut a bunch of lemons, I'm slowly dulling my knife because that's eating up the edge. And so, corrosion resistance is great. And B, it's tough enough that fundamentally, some people say that toughness doesn't matter for kitchen knives. They're wrong. Like, if I am chopping with my kitchen knife on a cutting board, it is a classic cyclic fatigue setup. I'm doing loading, unloading cycles over and over again, and that's how things fail right there. There are all sorts of tiny little notches on your edge, all sorts of stuff like that are going to cause microchipping. And so that toughness is super important.
There was one thing that you mentioned that really caught my attention. If it rhymes, it's true. So if we have, like, let's imagine imaginary scenario. We have two kitchen knives, one made from carbon, another made from stainless steel. Hardness, toughness, wear resistance is the same, but the corrosion resistance is not the same. And if I am cutting lemons, tomatoes, or anything that is extremely sour, whatever, then it means the carbon steel will dull faster because of the corrosion of the edge?
It depends on the primary wear mechanism, right? So if I'm cutting lemons on a granite stone, right, they're going to dull at the same rate because both of them are going to roll immediately when you hit the granite. But under a scenario in which, like, the controlling factor is corrosion, then yeah, of course. But then you've kind of just defined a circular logic right there, where yes, when corrosion is the main factor, then the stainless steel does better than the carbon. My point is that under a lot of modes, it's going to contribute. And like, one of the things, especially if you look really into corrosion science, is that your surface quality matters a lot to how objects corrode. And what corrodes the fastest is really thin things that are put out into your medium, because that surface energy is just so high. And our edges are extremely thin. And so they can corrode at not insignificant rates, even if the rest of your blade looks fine.
No, I mean, for the circular definition, if I'm a guy who is running a lemonade stand, I have a stainless blade and a carbon.
Oh yeah, obviously, yeah. Take your stainless blade, of course. Yeah, I mean, you should. Yeah. I think that the main thing in what you said is, in the stainless versus carbon blade, like truly stainless versus carbon, not high alloy, is you said at the very start, hardness and toughness is all the same. But here's the thing. Sure, you remove them, but here's the thing. At the end of the day, that's not true. Like, ever. Almost always, your stainless blade, if it's a good stainless, like you're not picking a bad stainless, has better toughness per hardness balance than a plain carbon steel. And so why not get the best out of both worlds?
That just makes sense, and it kind of reiterates the thing that, as you said about the conditions and the granite, if you are a maker and doing, like, trying to dial in your heat treatment and blah blah blah, just have the perfection. In my mind, it really comes down to the user and his culture on using the knife. Do you do it properly? Like, I've seen guys that are using outdoor knives and they are like, this MagnaCut cuts like shit, and they are, what they are doing, they are like sticking their knives into the ground for, like, just resting. And I'm like, dude, it does not matter how much effort I put into it if you don't know how to use your knife.
Sure.
I think before we move into the end of this episode, let's see if we can push Alwood's buttons a little bit, because you mentioned MagnaCut making some other steels obsolete. Would you say that MagnaCut has made RWL34 obsolete?
No, because you can't polish you can't polish MagnaCut the same way you would polish RWL34. You know, fundamentally, if you don't have diamonds, you are not cutting those abrasives. It's good for there are a lot of kitchen knife people who are like, there's a particular sort who are really into polishing and sharpening, and are really into the edges they can get off of all sorts of Japanese stones and whatever. And those are all going to be, you know, aluminum oxide or some non-diamond abrasive. And for those purposes, RWL34 is a great choice. I still stock a whole bunch of CPM 154, which is, you know, same thing. And it's for that reason. It's because it's a good steel for people who don't have diamonds to sharpen on.
Albert?
What?
You gonna back up?
No, I'm a fan of RWL34, as you guys know.
Do you use it on kitchen knives also, though, or just outdoors?
No, kitchen knives. So whenever we do a stainless kitchen knife, we use RWL34. Also for all the steak knives we made. So whenever corrosion resistance is an issue, or might be an issue, we're going to use RWL34 because it's readily available over here, because it's a Swedish company, Dama Steel. So it's easy to get. Especially compared to the CPM steels from the US, like MagnaCut. So MagnaCut was very expensive and very hard to get over here. So that's why we went for RWL34. And it's way cheaper, by the way, also. So we thought that's a good compromise. I mean, talking about RWL34 being a compromise, which sounds ridiculous because it's an awesome steel, but yeah.
Yeah,
that's
it's
what
great.
we went for, yeah.
Before all these crazy steels came out, that was like a really popular choice in hunting knives. You know, back in like the early 80s, and so a lot of the well-known famous knife makers, that was like an exclusive steel for them.
You mean RWL34? No, it was
that old, is it?
Yeah, no, it's not. It was the one before that. The
ATS.
Yeah, the ATS 34, exactly. Yeah, so the non-stainless version.
154 CM, the non-powder metallurgy version, was around for a while. It's a great steel. Like powder metallurgy really took that steel from like not that great to pretty darn good. That was a big change. I like working that stuff still. That's definitely a big fan. And yeah, I mean, it's what you said. It's nice to polish. It like actually grinds well. And it's good for like the everyday home user. And the only thing you lose out is a little bit of performance if you're willing to deal with the extra cost of all the grinding and stuff. Like, that's what it is.
And buying the steel. I mean, MagnaCut is way more expensive over here than RWL34.
Oh, I bet.
Yeah.
It'll be interesting with the Aerosteel stuff. Well, it won't make any difference to you guys because they probably ship it here, have it rolled, flattened out, and sold, and then ship it back there.
Yeah,
exactly. This is what they do. We need to get rolling here.
Yeah.
But your PhD thesis, does it have to do something with knife making? What is it going to be about, or what is it about? Because you said you're doing your PhD.
No, not really. I study automotive steels, so I study steels for transmission shafts, axles, that sort of thing. And we're looking at continuously cooled, bayonetic grades. And so I do bainite stuff, which is not something that a lot of, knives are made out of, for probably good reason. But it's a different world.
If you buy from Pakistan, you can get all sorts of things. So I guess. So you say their Damasco is made from Toyota bumpers and shafts.
Oh, I'm sure.
It's not good.
Probably not good. Probably not good. Although there are some pretty crazy steels that go into the. You could probably make a knife out of the A pillar of a car these days if you could get the steel out there. That stuff hardens to like what? Probably like low 60s. Probably the peak hardness you could get out of it if it's the right stuff. So it's
never thought about it.
Pretty impressive.
I would imagine you should maybe bearings, but the A pillar,
yeah, sure.
That's insane. Is it like
you
the
have to-
A-pillar?
Yeah, you have to be careful with bearings because the bearings could be carburized, so just the surface is hard. But there are a lot of very high strength steels in cars. You can probably make a knife out of a car axle if you pick the right one. It's like 45 carbon. It's like the lower end of you could get it 60, 62 maybe. I don't know. That's pretty good.
Hey, describing like half of the Forge and Fire episodes.
Yeah, exactly. Oh boy. You guys get the. Oh, you're a knife maker. Have you seen Forge and Fire?
Oh, of course.
Yeah,
Who hasn't?
everyone all the time.
100%.
You should go on Forge and Fire.
Yeah. What was? Oh, I have one thing. I have one interesting thing to share with you all. But part of mine's is, of course, because we have all these metallurgists in one room, and there's a pipeline of knife makers to metallurgists. Is that we have a knife making class that like undergrads can take for credits, which is pretty cool. I think it's the only one in the country, I'd guess. But I've been TAing that and working with a professor on that. And we're probably going to start up a segment where we do like an Ask a Metallurgist segment. So, all the people out there listening to the podcast, keep an eye on my Instagram or something, and there'll be some information on how to get your burning questions answered by, one person who's actually certified to, and me.
So the Instagram is minds_bladesmithing, right?
That's that one. And then you can just look at mine. I'll co-post everything so it's easier to find.
I was looking at it. I'm like, I don't understand what that is. Is that classes? All these people are making knives. What's going on here?
We teach undergrads to make knives, and they get college credits out of it.
Do they like it? Oh my god, you can
pretty
get
cool.
credits
God's
and make a
work.
knife?
Absolutely. We do force them to learn a whole bunch of metallurgy while they're at it, but that's one of the benefits of having a class that is extremely popular, is that you can get them to jump through a lot of hoops in order to learn things, which is great.
I mean, do you force them to hand sand to get
Hand sanding is part of the class, yes.
Got them.
But if you're a knife maker, you got to learn to hand sand. You got to do it. You can decide once you know how to do it, you can decide if you're going to do it or not.
I decided to not do it. I hand sanded my last knife 2 years ago.
There you go.
I'm like, I'm never gonna do this again.
There
I'm
you
just
go.
wasting my time. I don't
There
want
you
to
go.
do this. Yeah.
Yeah, but you did some before, Polly. That was the point.
I did.
There you go. You know the suffering.
Yeah.
You have to understand the suffering before you can choose to not do it.
Yeah. Now I feel sorry for it. I was like, the world would be so beautiful if people would not hand sand. Like so many happy bladesmiths. I mean, just accept the bill.
Oh, I love hand sanding. I just go and I watch a show and I hand sand, and it's the chillest part of my day.
But
You
Polly,
are one of those.
I think your knives, they look way better with the belt finish the way that you do them. I think they wouldn't be as nice if you hand sanded them, in my opinion. It shows like the ability, to come off the grinder with a nice looking finish like that, right?
Oh, absolutely. If I wasn't terrible at machine grinding, I'd probably not hand sand either.
So you're saying hand sanding is what everybody does to hide their horrible grinding? Is that what you're saying?
Exactly. That's what I do.
It's a shortcut, but it's not worth. Just learn. Or do outdoor blades. It's way easier. Hand to do like full flat, huge chef knife. Nah, thanks, but nah.
I would say the full flat grind is also a way to hide that you can't do a really good belt finish either. It's probably the easiest grind in the world.
Yeah, just full
it like grinds
flat.
itself.
Yeah, I don't do full flat. I do. Yeah, I don't know how I would even machine finish mine. Like how I would get all the convex bits to like actually have scratches that line up, but
rotary platen.
Yeah.
Just blend.
I figured it'd be something like that. It sounds awful. Sounds like
dangerous.
A huge pain. Yeah, there you go.
Why dangerous, Polly?
I had a buddy of mine, the rotary platen edge caught the blade and actually cut in the belt.
See, that's what I'd be worried about, especially with like the super thin kitchen knives and everything. It's just like push it in just a little bit and it's gonna spin out at you or something like that.
Like, I was not afraid of using the rotary Python, but after he said it to me, like, it never happened to me. I never had a belt split on me ever. But now it's always in my mind.
Yeah.
And now you're going to the grinder with fear in your eyes.
You just ruined it for me now. I never even thought of that either. Like if the belt's like riding over a little bit and you got some rubber showing, that it catches the rubber like so easily. Jesus Christ! Does anybody want to buy? Does anybody want to buy a rotary Platen?
For cheap.
It has happened like a million times to me. Just man up, guys. I mean, it's nothing to be worried about. I mean, you get used
Alan
to it.
He only has 9 fingers, by the way.
Yeah. 8 now.
Yeah.
8 Keith.
Awesome. We are like well over the 1.5 hours. It was an awesome show. We talked about a bunch of stuff. We'd definitely love to have you back on. And we even had maybe an idea of getting one of our Austrian Metallurgy buddies on here. We'd maybe discuss some stuff with you if you were into that.
Love to chat steel anytime. Feel free to, DM me anytime with steel questions. I'm always happy to help.
Can you quick tell everybody maybe where they can find you? Maybe get some of these knives when you get some available.
You can find me. It's a good question. Oh, there we go. You can find me at Troopah Knives on Instagram. That's probably the best way to contact me. Just shoot me a DM. I tend to reply back pretty fast. Good luck getting knives when they're available. Next knife I should have is being M2, I think.
And this is probably old, but you also have some Patreon content out there with heat treating charts and stuff like that on there, right?
I haven't posted on it for a while, so it's been paused, so there's no way to get on it. But if you're ever interested in an article that you can't get, just reach out to me and I'll hook you up.
Nice. Well, thanks again for coming on the show. You ran out today and bought a microphone just to get on here with us, so thanks again. And it was an awesome.
I needed a microphone anyway.
Yeah.
Thank you so much for coming.
Yeah, have a great one, guys. Great chatting with y'all.
Awesome. So we'll talk to the rest of you guys next week. Bye for now.
Bye-bye.
Bye for now. Tschüss. Auf Wiedersehen.
Bye-bye.
Yeah, the jingle. Everything works now. Keith is back. Support us on Patreon. High Carbon Podcast. Low Carbon episodes coming out.